Hello, everyone. Today's joke of the day is what do you call an old snowman? Stay tuned to find out. Our learning target for today is I can classify real numbers. So let's start with some definitions. A real number is going to be all fractions and decimals. Well, really, we don't need an and there. We want a comma. All fractions, decimals, and integers that you have ever encountered. Okay, so every number that we've encountered so far has been a real number. When you get to high school, you will learn about other kinds of numbers called complex numbers, but we don't need to worry about those right now. Everything you've seen so far is a real number. So some examples of real numbers include integers and whole numbers like 2 and 5, but also decimals like 0.3 repeating, or 0.5, or a fraction like 1/2, the number pi, or even like the square root of 7. Okay, those are all real numbers. Right? Every number that we have working with in this unit is a real number. Now we also have numbers called integers. Integers are going to be whole numbers their opposites, and 0. Okay, so integers are all of our whole numbers. Those are our counting numbers, like 1, 2, 3, 4, etc. Their opposites, so the negatives, -1, -2, -3, etc. And then also 0. Okay, so for example, we have some negatives, like -10, -5, 0, 3, 8. I'm just picking some random ones, 18, and 217. Okay, all of those numbers are integers. Now we also have a classification of numbers called rational numbers, and that's going to be any number that can be written as a fraction. Okay, any number that can be written as a fraction, which includes all of our integers. Okay, so all of our integers are included in the rational numbers. It includes all decimals that end. Okay, decimals like 0.78, for example. And then also repeated decimals. So like 0.3 repeating, like we used earlier. All right, so there's a bunch of examples of these, like we can include 0.5, that's a decimal that ends. 18 is an integer. -24 is an integer. 0.3 repeating, a decimal that repeats. Even a decimal that repeats two numbers, so like 0.45 repeating. 1/2, let's see, 0.75, another decimal. And like -2/3, that's a fraction. That would be a repeating decimal. But it can be written as a fraction. Okay, so that's a rational number. And then finally, our irrational numbers are numbers that cannot be written as a fraction. Okay, so numbers that cannot be written as a fraction are irrational numbers. This includes decimals that do not repeat, that like don't end, right? So that do not repeat or end. Okay, so for example, pi is an irrational number. It goes 0.341592, etc. Just keeps going and going. And then square roots of non-perfect squares are here. So like the square root of 26, for example. Okay, so the square roots of non-perfect squares are going to be irrational numbers as well. Now we can think of classifying numbers as a flow chart. Okay, so the first thing you need to do, if we know that it's a real number, which all of ours in this unit are, So we have to first determine, is it a rational number or an irrational number? Okay, so if we have a number, we first look, is it rational or irrational? Now, if it's irrational, that's it. That's the only classification. But if it's rational, then we look, okay, it's rational. Now, is it an integer? Is it a positive or negative whole number or zero? Or then is it a whole number? Okay. So the whole numbers are like 0, 1, 2, 3, and going on. Okay, and then is it a natural number? Now, natural numbers, those are our counting numbers, and we're not really going to talk too much about those. But that's all of the whole numbers except for 0. So just like 1, 2, 3, etc. Keeping on going. All right, so let's practice using this flowchart type of thinking to classify the following numbers. All right, first, the number 5. Okay, well, is it rational or irrational? And it is rational. We know that because it can be written as a fraction, right? We could write 5 over 1. All right, so because it can be written as a fraction, we know that it's rational. Why is this not letting me erase? There we go. Okay. So we know that it is rational. All right, and is it also an integer? And yes, it is. Okay, so it's rational. It's an integer. And then we think, okay, the next thing is it a whole number? And yes, it is, because it's positive. And then is it a natural number? Well, it's not 0, so yep, it's also a natural number. Okay, so the number 5 has a lot of classifications. Now let's look at this number -4 here. Well, first, is it rational or irrational? Well, just like that one, we can write it as -4 over 1. That's a fraction. So great, we got that. Then so we know it's rational. Okay, then the next question we ask ourselves is it an integer? And it is. It's an integer. And then the next thing is it a whole number? And it's not, because it's negative. So -4 is just rational and an integer. All right, let's look at pi here. Well, pi is one of our examples of an irrational number. All right, we know that right away. We just know it's irrational. And that's it. Okay, once it's irrational, there's no other classifications. All right, then here we'll look at the square root of 43. All right, well, the square root of 43 is not a perfect square, and the square roots of non-perfect squares are all irrational. So yes, square root of 43 is an irrational number. Okay. And then finally, let's look at this one, the square root of 49. Now, this could actually be simplified because we know that 49 is a perfect square, and so the square root of 49 is going to be 7. And then we just want to classify 7, okay? So let's classify 7. Let's see, 7 is a rational number. It is an integer. And then it's also a whole number. And it's a natural number too. So make sure that you always simplify all of your numbers before trying to classify them, because sometimes you'll miss a category if you don't simplify it. All right, so for today's joke of the day, what do you call an old snowman? A puddle. Thanks for watching and have a great day.